Okay, today we're going to do a few more simplifying radical problems from section 9.1. So in your spiral, please take out your spiral, label it 9.1 notes. So you did have homework due today, chapter 9, day 1. If you did not do it, you can finish it up today. I'll check on it tomorrow. So the first couple problems that we're going to do together are just some review. So we have the square root of 18 plus the square root of 32. So we'll have to break these down. So the square root of 18, you can do this a few different ways. So if you look at 18, you know that it's 9 times 2. So if you can find a perfect square, which 9 is a perfect square, that actually makes it go a little bit faster, because then the square root of 9 is 3. The square root of 2 is not an integer, so we would just keep that inside the radical sign. Now over here, the square root of 32. So if you can think, hey, it's 16 times 2, square root of 16 times the square root of 2, then you know you have the square root of 16, which is a perfect square of 4, and then the square root of 2 stays inside the radical sign. Now, these are able to be added together because they both have radical 2. Think of this like 3x plus 4x. They are like terms because they both have a variable of x. Well, that's the same thing here. They are like terms because they have radical 2. So when we add these together, you end up getting 7 radical 2. And that's your final answer for that problem. So we'll label that 1 for our notes. Number 2 for the notes. We have square root of 12 minus the square root of 48. So the other way to do this, I said there was a couple different ways, is we can do the factor tree. So you can say, okay, 12 is 6 times 2, and then this is 2 times 3, and here are all your prime numbers. So when you think the square root of 12, you have 2 times 2 times 3. Well, these are a pair, so they can come out as 1, 2, and you have radical 3 left over. All right, so that's another way to do it. Or if you can think of a perfect square, well, you have the square root of 4 times the square root of 3. Square root of 4, well, that's 2. And then you have 2 radical 3. So either way, let's do this one by prime factorization. So 48, we can think, all right, that's 2 and 24. 24 can be broken down into 8 and 3, among other things. And then we have 4 and 2, and we have 2 and 2. Now I realize that this way takes a little bit longer, but it is foolproof. It'll work every time. So we have the square root of 2 times 2 times 2 times 2 times 3. So here we have 2 2's, another 2 2's, take them out, 2 times 2 times radical 3. So the square root of 48 would be 4 radical 3. So now, I'm going to write it up here. Square root of 12 simplifies to 2 radical 3. We are now going to subtract 4 radical 3 because that's the square root of 48. When you subtract, you get 2 minus 4, negative 2, radical 3. Just think of the radicals like a variable, x, and it follows the same rules. Okay, number 3, another practice problem. Okay, so for the next problem, we have, number 3, radical 28 minus 3 radical 7 plus square root of 63. All right, so for this one, let's break down 28. So I'm going to try, I know that the square root of 4 times the square root of 7 would work, minus 3 root 7. And since 7 goes into 28 and we have the radical 7 here, does 7 go in here? And the answer is yep, you would have 9, square root of 9 times the square root of 7 to get to square root of 63. Okay, so now we have the square root of 4, which is 2. 7 is prime, so it's going to have to stay in the radical sign. Minus 3 radical 7 plus square root of 9 is 3. And then you could say radical 7 or root 7. And now it's just like 2x minus 3x plus 3x. So these two are going to cancel because you have negative 3x, or I'm sorry, negative 3 root 7 plus 3 root 7, they go away. So your final answer is 2 root 7. Number 4. All right, number 4, we have the square root of 200 minus the square root of 242. So when I think of a perfect square, what perfect square goes into 200? 100. So I have the square root of 100 times the square root of 2 would give me square root of 200. Before I take away the square root of 242, let's simplify this. 10 root 2. And the reason why I simplified it is because when I think the square root of 242, I'm not super strong on, hey, what goes into 242? However, because you have this radical 2 here, I do know that 2 goes in there because it's even. So if I had square root of 2 times what gives you 242, and the answer is the square root of 121. And that works out nicely because 121 is a perfect square. So the square root of 121 is 11. So now we have 10 radical 2 minus 11 radical 2, which gives you negative 1 radical 2, which we don't usually write the 1, so it's just negative radical 2 as your answer. All right, number 5. All right, let's do the square root of 8 times the square root of 2. So when you look at this, this is a little bit different. This is simplifying the expression still, but the radical 2 is prime. There's nothing that can come out of it. And then radical 8, we can take out root 4 times root 2 and simplify that. But another way to think about this is this means the square root of 8 times 2, square root of 2, which gives you the square root of 16, which simplifies nicely into 4. All right, number 6 is, and before we move on, if you wanted to do square root of 4 times square root of 2 times radical 2, we'd still get the same answer. We'd get 2 root 2 times root 2, and it's multiplication, so these can be multiplied. They don't have to be like terms. So then you get 2 root 4, which is 2 times 2, which eventually you still get the same answer. All right, number 6. We have square root of 12 times square root of 3. And again, 3 is already prime, so we're going to multiply across 12 times 3, and that'll give us the square root of 36, which gives us a nice answer of 6. Realize we're not doing plus or minus because it's not x squared equals 36, it's just what is the square root of 36? 6. All right, number 7. So for this one, we're going to have the square root of 2 times 3 root 2 plus radical 5. So here's the deal. We cannot add these two together because they're not like terms. So with addition, just like with variables, the square roots have to have the same radicand inside, and they don't. So let's distribute. So we have 3 times the square root of 4, because since radical 2 and radical 2 are both underneath the radical sign, they get multiplied together. So you get 3 times the square root of 4 plus 2 times 5 is square root of 10. So here we can do 3 times square root of 4 is 2 plus, and if you want to simplify that all the way, go for it. You can say that it is 6. All right, square root of 10, we have the square root of 5 times the square root of 2, neither of which can be simplified anymore, so we're just going to keep it as the square root of 10. We can't take anything out. There's no doubles. There's no perfect squares from 10, so this is your final answer. You cannot add these together. It would be like 6 plus x. You can't add them together. They're not like terms. So, all right, let's erase that. Number 8. So number 8, we're going to have the square root of 7 times 3 radical 5 minus the square root of 20. So we're going to distribute. Push my paper up. And we have 3 times the square root of 35 minus the square root of 140. Okay, so when I first look at this, I know that I distributed, but then this is a rather large number. And I think 20, I know that I can get a 4 out of this. So I actually want to simplify this first when I relook at this. This could be the square root of 4 times the square root of 5. So we have 2 root 5. That's one thing about these problems. There's no one way to get to the final answer. So I'm going to actually redo it and look at it this way, because then when I distribute, I get 3 radical 35 minus 2 radical 35. And now these two are like terms. 3 minus 2 would be 1, square root of 35, and you usually don't write the 1 in front, so your answer is just square root of 35. And you cannot simplify that. 9. So we're going to do square root, in parentheses, square root of 3 plus 2, close the parentheses, and we're going to square that whole entire expression. A common mistake is that people just distribute this square to the 2 terms inside. That doesn't work. Please realize that this means square root of 3 plus 2 times square root of 3 plus 2. The whole expression needs to happen twice. So now we can FOIL, and we have square root of 3 times the square root of 3, which is the square root of 9. And then we have the square root of 3 times 2, which would be plus 2 root 3. And then 2 times the square root of 3, again, plus 2 root 3. And finally, 2 times 2, which is 4. So square root of 9, I'm going to replace this with 3. So we have 3 plus 4, they're like terms, so we have 7. 2 root 3 plus 2 root 3 gives you plus 4 root 3. And that is your final answer for that problem. Okay, number 10. Another similar one. 4 minus the square root of 5 squared. So you can also use the shortcut. Do you remember a minus b squared would be a squared minus 2ab plus b squared. So if we did that, we would have 4 squared minus 2 times 4 times square root of 5 plus square root of 5 squared. So 4 squared is 16. 2 times 4, that would be 8 with your radical 5. And then the square root of 5 squared, well, a square and a square root cancel, so you just get plus 5. So then combine the constants, the like terms, you have 21 minus 8 root 5. That's another way to do it if you didn't want to write out the 2 expressions in parentheses and FOIL. You could use the shortcut. All right, number 11. Let's do a different type of problem. Number 11, we have 6 over the square root of 3. And 12 will be similar. We will have 5 over the square root of 5. So the rule is you're not allowed to have a square root in the denominator. So to get rid of it, you multiply it by that same square root, because what happens is the square root of 3 times the square root of 3, which would give you the square root of 3 times 3, which is 9, and really that's just 3, okay? So whatever you do to the bottom, you have to do to the top, because essentially you're just multiplying everything by 1, and anything by 1 is itself. So whatever we have here will equal the same thing we get, because we're just multiplying by 1. So here we have, I'm just going to skip over here, 6 root 3. Now we're not completely done, because when you look at the numbers in front, again, if this was like 6x over 3, you would simplify and say, oh, it's 2 and 1, so you got 2x. So we're going to do the same logic here. 6 and 3 can be simplified, so your final answer will be 2 root 3. And that's your final answer for number 11. Okay, number 12, some of you might have already done it, but you're multiplied by the radical 5. We're going to skip over, at this point you should know radical 5 times radical 5, that'll give you square root of 25, which is just 5. And then here we have 5 root 5. And how nice, they both have 5 as the coefficients or the constants, so we have 1 and 1. So our final answer is just the square root of 5. Okay, last type of radical problem. Let's write 3 over 4 plus radical 2. So the way you simplify this type of problem, we cannot have a radical in the bottom, so we need to get rid of it. And the way that you do this is you multiply both top and bottom by the same thing, and this time we're going to multiply it by 4 minus square root of 2 on both top and bottom. So look what happens. If we have 4 plus square root of 2 times 4 minus square root of 2, you can think of these in parentheses, and you're going to FOIL. So 4 times 4 gives you 16. 4 times negative square root of 2 gives you minus 4 root 2. Radical 2 times positive 4 gives you plus 4 root 2. And then radical 2 times negative radical 2 gives you negative square root of 4, which can simplify to minus 2. So what you can see here is that we have negative 4 radical 2 plus 4 radical 2. They cancel. And then we're left with 16 minus 2, 14 in your denominator. Okay, so now we have to distribute on top. It's not as hard. So we have 3 times 4, which is 12, minus 3 times square root of 2, which is 3 root 2. So that will be in our numerator. So we have 12 minus 3 root 2. Now, if we look at 12, 14, and 3, is there any number that goes into these three numbers? And the answer is no. Once you check that out, if you cannot simplify it anymore, that's your final answer. All right, and the last type of radical problem, I believe this was problem 13, this will be 14. We have some different problems after this. Let's do 1 over the square root of 3 minus 2. So to solve this one, you're going to multiply it by the square root of 3 plus 2. So FOIL it. So on the bottom, and you're going to multiply the numerator and the denominator both by radical 3 plus 2. So if we FOIL radical 3 times radical 3, we end up with 3, because it gives you the square root of 9, which is 3. Radical 3 times 2 gives you plus 2 radical 3. Negative 2 times radical 3 gives you minus 2 radical 3. And then negative 2 times positive 2 gives you minus 4. All right, so we can simplify that right now. These two go away, and then 3 minus 4 in the denominator will have negative 1. On top, well, if you just distribute 1, you end up with the same thing that you started with, so the square root of 3 plus 2. Now, here's the deal. We have this divided by negative 1. So when we divide by negative 1, the signs will change here, and you'll end up with negative radical 3 minus 2. And usually they end up putting the radical as the second term, so negative 2 minus the square root of 3. Okay, well, let's do different types of problems. 15, I believe, for our notes. All right, we have the quadratic equation, and I know that some people struggled with this on their homework, so let's do a couple of these. So, yes, you can use the quadratic formula, and some of them cannot be factored, so you need to use the quadratic, but let's see if we can factor these. So, in front, we have a 2. So we need to do what factors are there of 2? So we have 2 times 1. And then what factors of 3? 3 times 1. So this is nice and pretty simple. What this means is in front we're going to have 2x and we're going to have an x, because when you FOIL, 2x times x will end up giving you 2x squared. Okay, in the back we either are going to put the 3 here and the 1 here, or we'll put the 1 here and the 3 here. What we need to figure out is which of these combinations will give us 7 when we FOIL. So let's just right now, let's put 3 here and 1 here. So really what you need to look for are the extremes. So 2x times 1 would be 2x, and then 3 times x would be 3x. When we add those together, we're not going to get 7. So this was not the correct placement. So instead, let's put 1 here and 3 here. And now when we do this, 2x times 3 is 6x. 1 times x would be 1x, and that will give us our 7x that we need in the middle. So what we have is 2x plus 1 times x plus 3. And some other rules you need to know, since this is a positive 3, these two signs must either both be positive or they both need to be negative, because when you multiply 3 or 1 times 3, you need to get positive 3. So it's either going to be positive 1 times positive 3 or negative 1 times negative 3. But since this is a plus sign here, they both are positive because we need them to be a positive 7. So let's solve here. We have 2x plus 1 equals 0. So we subtract 1, 2x equals negative 1, divide by 2, x is equal to negative 1/2. And here, x plus 3 equals 0, x is equal to negative 3. So those are your two answers for that problem. All right, let's do a problem that doesn't simplify as nicely. So number 16, let's write down 2x squared minus x minus 2 equals 0. And you can try to factor it, but it's not going to work out. So as I'm sure you remember, we have the quadratic equation. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So this is a, the negative 1 would be b, and negative 2 would be c. So let's plug those numbers in. We have the opposite of b. So let's write over here. A equals 2, because that is the coefficient in front of the x squared. The coefficient in front of x would be a negative 1. So we have b equals negative 1, and c equals your constant. So c equals negative 2. So now let's plug these numbers over here into the quadratic equation. So x equals the opposite of b. So we have 1 plus or minus the square root of b squared. So we have negative 1 squared minus 4 times a, which is 2, times c, which is negative 2, all over 2 times a, which is 2. So then 1 plus or minus square root. So if we have 1 squared is 1, minus 4 times 2 is 8 times negative 2, negative 16. So minus negative 16, it's actually plus. So it's 1 plus 16 all over 4. So then finally we have 1 plus or minus 1 plus 16 is square root of 17 over 4. We are done because 1, 4, and then there would be a 1 here. There's no numbers. You can't simplify those anymore. So that is your final answer for this problem. All right. Next problem. You guys should know how to use quadratic, so let's do the next type of problems. I'll just do a few of these, and then you can start your homework. So, I forget, we were on number 16, so this will be 17. So if we have something like this, let's do the square root of 16 over 25. This one's pretty easy. What I want you to remember is that you can simplify this into two smaller square roots. So you have the square root of 16 over the square root of 25, which is 4/5. Call it a day, you're done. All right, but let's make it harder. Let's do 2 square root 15 over 3. So if we were to make these, we have the 2 outside, but if we were going to make these into smaller square roots, we can't do anything. There's no perfect square that comes out of 15. This is prime, so there's no perfect square there either. But we can't leave a square root in or a radical in the denominator, so let's multiply both of these by square root of 3. So now I'm just going to bring the 2 over, and the square root of 15 times the square root of 3, that's going to be the square root of 45, which we can simplify in a second. Square root of 3 times the square root of 3, well, that's just going to be the square root of 9, which is 3. All right, now we have to simplify the square root of 45. So the square root of 45 can break down into 9 times the square root of 5, which 9 can become, square root of 9 can become 3, so we have 3 radical 5. So let's rewrite this. We have 2 times 3 radical 5 over 3. What you need to understand is that this 2 is over 1. So now we have 2 times 3, which is 6 radical 5 on top. 3 times 1 on the bottom is just 3. And then these can be simplified, 1 and 2. So your final answer would be 2 radical 5. All right, so that one's a little bit more difficult. All of your problems are going to be like this. Let's just do one more challenging one, and we'll call it a day on notes. So we have the square root of 3 times the square root of 20 over the square root of 5. So a couple ways that you can look at this. You could multiply. Remember I said this is over 1. So you can multiply the square root of 3 times the square root of 20 on top over the square root of 5. And this would give you the square root of 60 over the square root of 5. And then we can multiply them both by 5, the square root of 5. And on bottom, square root of 5 times the square root of 5, that would just give you 5. And this would be the square root of 300 on top. So then to simplify this, this would be square root of 100 times the square root of 3. Well, square root of 100 is 10. Square root 3 all over 5. Then when we simplify, this goes to 1, this goes to 2, so your final answer would be 2 radical 3. That's one way to do that. You could do a different way. Like I said, there's not necessarily one way to get the answer. So we could have just multiplied this by the square root of 5, taken the square root of 3 along for a ride, and then 20 times 5 gives you square root of 100 over square root of 5 times square root of 5 is 5. So again, just bring the square root of 3 along, and then we have square root of 100 would be 10 over 5, and this would simplify to 2. So square root of 3 times 2, which gives you your final answer of 2 root 3. So just because you're not doing it the same way as maybe a person next to you doesn't mean you won't get the final answer in the end. So for the remainder of the class period, I want you to work on your worksheet. So you have a 9.1 worksheet. That's your actual homework for tonight. And then if you didn't do it already, you had to do Chapter 9, Day 1. It was due today. So if you already did it, great. You don't need to do that. But if you didn't already do that, then you have both of these to do.